Let's try some heparin calculations. Let's look at our first problem. The order is for 500 milliliters of normal saline IV with heparin 25,000 units to infuse at 500 units per hour. They want us to find the flow rate in milliliters per hour and then find the daily heparin dosage in units per 24 hours. First, let's find the milliliters per hour. If we look at the amount of medication given in relationship to a time, we can see that 500 units is to be given every hour. They want us to convert this to milliliters per hour. If you notice, the only difference is the 500 units needs to be converted into milliliters. Therefore, we need to look back at our problem and find a relationship between units and milliliters. As you can see from the order, we have a relationship of 500 milliliters per 25,000 units. We can set this up using the rainbow method to solve for our unknown amount of milliliters. We know there's 25,000 units in every 500 milliliters. We have 500 units, and we need to convert that to milliliters. Remember, this 500 units was per hour, and this milliliters should be per hour. Nothing has changed, just we're converting the units to milliliters. We can now multiply our means and our extremes like normals to solve for our unknown. We have 25,000 units times X milliliters gives us 500 milliliters times 500 units. We can divide both sides by the 25,000 units in order to solve for our X. As you can see, when you perform the operation 500 milliliters times 500 divided by 25,000, we end up with 10 milliliters, and the time is still in per hour because we never changed it. Now let's try to answer the second question. They want us to find the units in 24 hours. Well, we know how many units there are in 1 hour. They want us to find the number of units in 24 hours. We again can set up a relationship between this. We know that there's 500 units in 1 hour. We want to know how many units are in 24 hours. We're going to multiply our means and our extremes. We get 500 units times 24 hours equals 1 hour times X units. When we divide both sides by the 1 hour, we find out that X equals 12,000 units. Therefore, in a 24-hour period, we will be giving 12,000 units. Let's do these same problems with a proportion method. Again, they're asking me to find the flow rate in milliliters per hour. They give me information that tells me how many units are per hour. They want to know the milliliters per hour. Because the time doesn't change, we can almost ignore the time here and just focus on converting the 500 units to an unknown number of milliliters. We have a relationship given to us between units and milliliters directly from the problem. We can see that there's 500 milliliters and 25,000 units. We then will cross multiply to solve for our X. 500 units times 500 milliliters will give me X milliliters times 25,000 units. We then will divide both sides by the 25,000. And in doing so, we will find that our X milliliters is equal to 10 milliliters. Again, this is still per hour because we never changed the time period we were talking about. If we look at the second part of the question, it asks us to find the units in 24 hours. We know the units in 1 hour, 500 units per 1 hour. And they're asking me to find how many units are in 24 hours. We can cross multiply to solve for our unknown. We have 500 units times 24 hours equals 1 hour times x units. When you divide both sides by the 1 hour, we will discover that x is equal to 12,000 units per day or per 24-hour period. Another way we can perform this operation is through the use of dimensional analysis. In this case, we're going to start with the infusion rate of 500 units per hour. They want us to convert units per hour to milliliters per hour. Ours is already at the bottom, so the only thing we need to do is find a conversion between units and milliliters that will cancel out our units and leave us with milliliters per hour. And we can see from the problem that there's 500 milliliters and 25,000 units. Units cancel. We end up with 500 times 500 divided by 25,000, and we discover we have 10 milliliters per hour. The second part of the question wants us to find the units in 24 hours. Well, they tell us we're administering 500 units in 1 hour. So to convert this into 24 hours, we're just going to have to multiply by 24 hours. And doing so, we discover that we're giving 12,000 units in a day or in a 24-hour period. The fourth way to convert these problems is by using the formula method. Again, we need to notice that the question is asking us for milliliters per hour, and we are given units per hour. The only difference between these two are we're going to convert the 500 units into milliliters. Therefore, we're going to start with our 500 units ordered, and we're going to divide by the way it's being administered, the 25,000 units on hand that's delivered in 500 milliliters. The units cancel, we multiply across, and we discover we're giving 10 milliliters. And again, the time frame has not changed, so it's still per hour. Now to find the units per 24 hours, we know we have 500 units in 1 hour, so we just need to multiply this by the full day, or 24 hours, and we'll discover that we have 12,000 units in a day. This time, instead of delivering the heparin in an IV, we're going to deliver it as an injection. We have an order of heparin, 25,000 units, SC/BID. The supply is heparin 20,000 units per milliliter. How many milliliters do we need to administer? Well, again, we can do this calculation using all four methods. First, let's use the rainbow method. We need to find our relationship between units and milliliters. As we can see from the supply, we know that there's 20,000 units in every 1 milliliter. We are told we need to deliver 2,500 units, and we need to find out how many milliliters that equals. We can multiply our means and our extremes. 20,000 units times x milliliters equals 1 milliliter times 2,500 units. To isolate our x, we will divide both sides by the 20,000 units. In doing so, we discover that x milliliters is equal to 0.125 milliliters. Now, as this is a heparin dosage, we know we need to round to the hundredths place. The 2 is in the hundredths place, and the 5 tells us to round up. Therefore, we will administer 0.13 milliliters. We can do the same calculation using the proportion method. We will first set up a fractional proportion that shows the relationship between units and milliliters. We know we have 20,000 units in every 1 milliliter. We need to administer 2,500 units, and we need to find out how many milliliters that's equivalent to. To solve for x, we will cross multiply 20,000 units times x milliliters equals 1 milliliter times 2,500 units. To solve for x, we will divide both sides by 20,000 units. Therefore, isolating our x and getting milliliters by itself. When you perform the calculation, 1 milliliter times 2,500 divided by 20,000, you should get 0.125 milliliters. However, since we are administering heparin, we know to round to the hundredths place. The 2 is in the hundredths place, and the 5 tells me to round up. Therefore, we will administer 0.13 milliliters. We can do the same calculation using dimensional analysis. In this case, we'll start with the order of 2,500 units. We will then multiply by a conversion factor that will cancel out units and leave us with milliliters. As we can see from the supply, each milliliter holds 20,000 units. The units cancel. We multiply across 2,500 times 1 and divide by 20,000, and we discover we get 0.125 milliliters. However, since this is heparin, we need to round to the hundredths place. The 2 is in the hundredths place. The 5 tells us to round up. Therefore, we will give 0.13 milliliters. The last method is the formula method. In this case, we're going to take what the doctor ordered, 2,500 units. We're going to divide by the dosage on hand, 20,000 units, and multiply by the way it's going to be delivered, the 1 milliliter. Units cancel. We divide 2,500 by 20,000, multiply by 1, and we get 0.125. But again, since this is heparin, we know we need to round to the hundredths place, and the 5 tells us to round up. Therefore, we deliver 0.13 milliliters.